Hello, my name is Emma, and I'm going over how pharmacogenomics is revolutionizing how doctors prescribe medicine. So, have you ever wondered why a medication that works perfectly for one person causes harmful side effects for another? It's not luck, but it's actually hidden in our DNA. Every day, doctors prescribe medications hoping that they'll help more than they harm, but until recently, the process was mostly trial and error. But pharmacogenomics is changing that. It's helping doctors match prescriptions to our genes and brings us closer to personalized medicine. So, what is pharmacogenomics? Well, pharmacogenomics combines two sciences. That's pharmacology, the study of drugs, and genomics, the study of our genes. It examines how small variations in DNA can change the way our bodies respond to medications. Some people break down a drug quickly, while others slowly, and some need higher doses to see results, while others experience side effects at even small amounts. So, by studying these genetic differences, scientists and physicians can predict how a person will react to a medication before they take it. This is the foundation of precision medicine, which is treating each patient based on their unique biology instead of a one size fits all approach. In this diagram here, you can see the many factors that contribute to a drug response, and because of those factors lead to a personalized pharmacogenomics, and then from that, we can lead to personalized medicine. Let's take a look at a real example. Warfarin is a common blood thinner used to prevent strokes. It's a life-saving medication, but finding the right dose can be tricky. Too much can cause internal bleeding, and too little leaves a person at risk for blood clots. So there are two major genes that play a role in here, which is CYP2C9 and VKORC1. CYP2C9 affects how fast the body breaks down the warfarin, and VKORC1 determines how sensitive we are to it. A pharmacogenomic test can identify a patient's versions of these genes, helping doctors choose the safest starting dose right away. In fact, study shows this approach can reduce hospitalizations from adverse drug reactions by more than 30%. This is one small example of how reading our genes can directly improve patient outcomes. On here, I have a diagram from the case study of a specific case on a 52-year-old male and his personalized pharmacogenomics dosage for warfarin. So, how does this work in practice? Well, it begins with a DNA sample, often from a cheek swab or a blood test. The sample is sequenced to find genetic variants that affect how drugs are metabolized. So, that information is entered in a clinical database, and doctors receive personalized dosing recommendations. Instead of guessing and adjusting later, physicians can measure first and then prescribe second. So it's medicine guided by data and not trial and error. As powerful as pharmacogenomics is, it brings real world challenges that we can't ignore. One of the biggest questions is who controls our genetic data once it's collected. Well, most genetic tests are stored in hospital databases or shared with third party labs, which means our information can move between systems. That's why data protection laws like the Genetic Information Non Discrimination Act, also known as GINA, was created. GINA prevents employers and health insurers from using our DNA to discriminate against us. The future of pharmacogenomics is already taking shape. Many hospitals are already starting to include pharmacogenomic panels in their electronic health records. And looking ahead, technologies like CRISPR gene editing might even allow us to correct the variants that cause harmful drug responses altogether. What once seemed futuristic is quickly becoming a normal part of clinical care. Pharmacogenomics reminds us that medicine isn't just about treating diseases, but it's understanding our differences. By learning how our genes influence the medicines we take, we're creating a world where every prescription is safer, smarter, and more personal. In the future world, your own DNA helps write the prescription that saves your own life. That's pharmacogenomics, and that's an idea worth spreading. And I'll be closing out with my four references.